Now we move on to the next question, that is, a mass weighing 4 pounds is attached to a spring whose constant is 2 pounds per feet, and the medium offers a damping force that numerically equals the instantaneous velocity, and the mass is initially released from a point 1 foot above the equilibrium with a downward velocity of 14 feet per second. So this one will be treated as negative and this quantity would be positive. So we have to find the time at which it first passes the equilibrium position. So what we would do again is we will go ahead and I'm just going to use the equations editor. Okay, so here we go, and again so I got this. So what we have is it is 4 pounds, so the force created is 4 over 32. 32 is the acceleration due to gravity. Okay, of course in the foot-pound-second system, and say y is the displacement at time t. So this force has to equal the damping is the instantaneous velocity, right? Dy dt actually, and the spring constant is 2 foot-pound, right? Okay, sorry, 2 pound foot I meant. Okay, and so here we have the equation. All right, so that gives us what? That will give us that that 1 over 8 d2y dt square equals the quantity written here, and I am trying to do it as close to as exam taking setting, but it cannot really be ideally done. So anyways, so here we are just multiplying by 8 there, right? So this becomes a 16, and now what we have is that we got if we move this part over to the left, the signs will change, right? So we have a plus sign here and a plus sign here, and equals 0. So let's write the auxiliary equation for the solution of this homogeneous system. So we got s square plus 8s plus 16 equals 0, that will mean that s plus 4 square equals 0, right? Okay, so what happens? We got negative 4 as repeated root, so our solution is going to be y equals c1 times e to the negative 4t, okay, and then plus another constant c2 times t times e to the negative 4t. We just multiply by t to create another linearly independent solution, and we have seen this indeed is a solution, right? And what else are we given? We are given that y0 is, if you recall, that it was released 1 foot above the equilibrium position, so that will be -1, and y prime 0 is 14 feet per second, so that's 14. All right, so if we put t equals 0 in here, then what you have is that y is -1. When t is 0, this quantity is 1, right? And because t is 0, this becomes a 0. So we got c1 equals -1, right? So here we go. So we have our y equals -1 times e to the negative 4t plus c2t to the negative t. Now we will determine the quantity c2 using this condition, right? So if we go for the y prime, what do we get? We get 4e to the negative 4t by differentiating the first part, okay? And then we get plus c2, okay? And then derivative of t is 1, so we simply get e to the negative 4t, right? And then we will differentiate this portion, so we'll get negative 4 c2 and then t times e to the negative 4t. Now if we just use the other condition here, y prime at 0 is 14, so what do we get? 14 equals 4, because this will become a 1, plus c2, right? Sorry, this quantity does become 1 and t is 0, so this will be out of the way. So what you have is, you have c2 equals, how much? c2 equals 10, right? So our y is how much? Y is negative e to the negative 4t, and this is 10. So the first part that we had to do was that at what time would would it cross the equilibrium position, for which y will have to be 0. So here we got y equals 0, and e to the negative 4t cannot be 0, so this simply translates to e to the negative 4t. We can just divide by that and multiply by e to the positive 4t, whichever way you prefer. So that will amount to this. So t is how many? 1 over 10 seconds for the first part. So let's just keep this on our notepad. So that's 1 over 10, and then you have y prime. Where did the y prime go? So we need this y prime, because next we have to find out what do we have to find out. Let me get the question portion back. Okay, here. That is, so we just found that this is 0.1, okay, and then the next part is asking that what time does it go to the extreme displacement, and at that place we know that the velocity will become 0, so that's why we needed the y prime. And so I think I had copied y prime. Yes, I'm right. So this part is how much? That's a 10. Remember, we found t2 equals 10, right? Now we need we need y prime to be 0, right, at t equals 0. So what we will have is, no, not at t equals 0, I apologize. We have to determine that value of t. Okay, so we got this, and actually just to carry less load, let's get this out, because 10 plus 4 is 14, and again as before, e to the negative 4t will cancel out here, okay, and we know this, that cannot be 0. So here 40 equals 40t, 14 equals 40t, and that gives us t equals 14 over 40, right? So 14 over 40, all right, and that's going to be, then we can change it to the decimal by using our calculator, or we can just do it directly. We know it is how much? It is 7 over 20, right? So that will become how much? 0.35, wouldn't it, right? Okay, so we can enter this as 35 here, all right, save it. And then the next part is, what is our next part? The next part is this, that is when does it pass through, okay, that is in numeric, at what, okay, to a mass weighing, I'm just position of the that we found in 3b, that is at what place will it have, I mean, or rather what is the maximum displacement, okay. All right, so let's go and compute the maximum displacement. So there what we have to do is simply take this value and substitute what? The time at which that maximum displacement will occur. So we got 0.35 here, right? Oh, sorry, not like that. Okay, so e to the power negative 4 times 0.35, okay, then 10 times 0.35, then e to the power, again, sorry, oh, that's why it was happening before, right? Okay, so let me just, okay, go like this, so negative 4.35, and now I'll just go ahead and use my calculator. Okay, so we have here negative e to the power, okay, negative 4 times 0.35 plus 10 times 0.35 times e to the power negative 4 times 0.35, all right, and that comes out to be 0.6165 approximately. So let's just go ahead and enter it, 0.6165, okay, and then here I would just go ahead and put my work in, all right, and would ask to save it. Or if I wrote it on my, on a paper and I want to submit it there, I think we have, yeah, so I can just go ahead and, do it this way, right? Okay, so anyways, so let's just go on to the next question now.